All right, and here we go again, right? Another day, another type of function, right? So now, all right, we're going to transfer what we know, all right, from writing equations of tables of quadratics to, once again, these various contexts. Now, the good news is you're going to hopefully see some connections to what we did in our last lesson with absolute values, all right? So, same kind of opener that we did last time, right? So once again, we want to kind of see, okay, does this pattern with A, all right, keep going? Does it translate to another type of function, right? We also talk about teaching you the master key, right? So what things transfer, right? Identifying the vertex transfers, right? Will this A value that we talked about and the effects of that A value transfer to quadratic? So once again, hopefully you can get 4 different colors, all right, and graph, all right, those functions right there. Now, once again, graph as many points as you can, understandably, all right? Some of them are going to go off the graph. You may only get the vertex and one other pair of points. That's totally fine. Then same thing. Now, this gets a little bit tricky with the fractions with a quadratic versus a absolute value. So just do the best you can when you're doing like 3a, right, 5a, 7a, whatever that happens to be. You might have to use your calculator, right, to do 1/2 times 3 or 1/5 times 3. And it gets a little bit tricky because there's not a lot of space for some of those numbers. So do the best you can. All right, so pause the video. All right, do this opener and let's see if what you know about A values, all right, from absolute values transfers to our quadratic function. All right, so here we go. All right, so once again, here are the colors, right? Red, blue, black, and green. All right, and then once again, all right, you can see the red here. This time is our parent function. So we have the parent function for every type of function, just like we did for our absolute value function, right? Vertex is 0, 0, A value is 1. And you can see, all right, blue, green, black, right? You can see that as the A value increases, our graphs get narrower, just like what happened with our absolute value functions. And then vice versa here, right? Okay, there's the red function. That's our parent function again. All right, and then as my A value gets smaller and smaller, my graph gets wider and wider. So that piece of knowledge, right, about the A value does transfer from function to function. It is the rate of change, right? So if that rate of change goes up, your function is going to increase faster, therefore your graph is going to be narrower. If your A value goes down, it's not going to increase as fast, all right, it's going to be wider. All right, so if we flip to the next page, all right, okay, there we go. All right, find the right page here. All right, as the A value gets larger, once again, the graph gets narrower, right? As the A value gets smaller, the graph gets wider. All right, so same idea. Once again, a master key, right? Okay, that's going to be true for all the functions you study, Algebra 1, Algebra 2, pre-calculus moving forward. All right, so now once again, we're going to start with table of values, right? Just to refresh our memory, writing equations quadratics, and then we'll move into, excuse me, we'll move into those other types of contexts. So once again, right, when we look at our equation, HK, that's our vertex, our turning point. Now remember, A, and this is a reminder, is our rate of change divided by 2. All right, so we got to remember that. All right, the A and the rate of change are not the same in a quadratic, slightly different. All right, so once again, let's look at our table in number 1 here. So once again, the first thing that we always want to do, scan that table. If you have a turning point, circle it. All right, that gets us down to 2 functions. So I see a turning point at 3, 2. So there's my vertex, right? Okay, I'm just going to add that right there. Now, once again, I know it's either absolute value or quadratic because of the turning point. So we jump into our rates of change to determine which of those 2 functions we have. So looking at our x's, we can see that they all increase by 1. Now let's look at our y's. 10 to 4, I go down 6. 4 to 2, I go down 2. So right now, okay, I know it can't be absolute value because I don't have a constant rate of change. Negative 6 to 1 does not equal negative 2 to 1. So this confirms, right, that it is a quadratic. All right, so remember on a test and an assessment, right, it's going to be all mixed up. So turning point, constant rate of change, absolute value. Turning point, non-constant rate of change, quadratic. Okay, and then we can keep going, right? 2 to 4, I go up 2, and then 4 to 6, or excuse me, 4 to 10, I go up 6. All right, so negative 6 to 1, negative 2 to 1, 2 to 1, 6 to 1. Now, remember from the rate of change of a quadratic, we look at the pattern here. How are these changing? Negative 6 to negative 2, I go up 4. Negative 2 to 2, I go up 4. 2 to 6, I go up 4. So our rate of change, right, we would say is increasing by 4. Now, then we take that to get our a value. So that goes back up here, right? So we take that value and we divide it by 2. So it's increasing by 4. That's a positive 4. We divide that by 2, and that tells us that our a value is 2. So I can take my a value, I can take my vertex, and I can put that into our equation, and there it is. Now, just like we did with an absolute value function, I can do a quick sketch to make sure my a value, at least has the right sign, whether it opens up or down, right? So negative rate of change, so I'm going down till I hit that vertex, positive rate of change, it opens up. Therefore, my a value has to be 2. Okay, now, once again, we're going to plug in 9 here. Okay, we're going to try to, plug in a and x value. This happens to be 9. So we're going to try to predict, what kind of point would I get, or what point would I get if I were to extend this table to 9? So once again, as this becomes an absolute value problem, once I plug in my value for x, and we always take care of those grouping symbols first, right? So 9 minus 3 is 6. So that's 6. All right, now I don't drop the parentheses yet because of this exponent. And that's what I have to do next, right? So grouping symbols, exponents. All right, so now 6 squared, right? So remember, 6 squared is 6 times 6. All right, and 6 times 6 is 36. And now I can do the multiplication. So 2 times 36 is 72, and then 72 plus 2 is 74. So if I were to extend this table, I would get to the point 974. All right, moving on to problem 2. See what you got here. All right, so scan that table. If you see a turning point, circle it. Circle it. Okay, I do see a turning point. All right, right here, -2, -5. Now, once again, make sure that you don't just assume it's in the middle. Now, in these two examples, it happened to be in the middle. It won't always be in the exact middle if you have one. So make sure you really do scan and don't just assume, okay? Now, once again, we know it's either absolute value or it's quadratic. And I keep saying these things to you because I want you to internalize those questions so that when you get on an assessment, right, you already know what to ask yourself. So let's look at our rates of change, all right? My rates of change for my x's all go up by 1. Now, -17 to -8 is an increase of 9. -8 to -5 is an increase of 3. So my first rate of change is 9 to 1. My next rate of change is 3 to 1. So what that tells me is it cannot be absolute value. I do not have a constant rate of change. So this confirms that it has to be quadratic. Now I hit my turning point, -5, -8. Now I've changed directions. Now I'm going down 3. -8 to -17, I've changed direction. I'm going down 9. Now let's look at the pattern in our rates of change, right? 9 to 3, I go down 6. 3 to -3, I go down 6. -3 to -9, I go down 6. So what's our rate of change? It is decreasing, right, by 6, all right, which is a -6. So now to get our a value, that's decreasing by 6. That's -6, and I want to divide that by 2, and that's -3. All right, so now I take that a value, and I take my vertex. X minus -2 becomes a +2, and then I have the little 2 on the parenthesis. Remember, that's what makes it quadratic, that exponent of 2. So make sure you include that. Otherwise, you'll have a linear equation, and you won't get the right value when we start predicting here in just a moment. All right, now, a couple of things to point out here. So the other thing we talked about is that first step in the rate of change after the vertex also represents your a value. So if I look here, my first step in the rate of change after my vertex is 2 to 1. You can see that that's our a value. My first step after the rate of change, or excuse me, after the turning point here, -3 to 1. All right, and see that that is our a value as well. So remember, there's a couple different ways to do that, and we want you to kind of know both because it's a good self-check. All right. Now, once again, let's predict. If I were to extend this table in reverse up to -10, what y value would I get? So y equals -3. And then I get -10 plus 2, and then quantity squared minus 5. Once again, let's jump in and complete those grouping symbols first. So -10 plus 2 is -8. Now remember, -8 squared is -8 times -8. Now a negative times a negative is a positive, and then 8, all right, times 8 is 64. So I get positive 64 there. And then -3 times 64, all right, that's going to be -192, All right, I left the negative off. I said it, negative 192 and then minus 5, and that gives us negative 197. So if we were to extend this table, we'd have negative 10, comma, negative 197, all right, for the point in our table. All right, so there's a review of everything. So now let's look at these other situations. So once again, right, here's what we know. This is everything that we've been doing with our regular quadratic function. And then once again, when we see the word parent function, all right, we know that it's a quadratic. The vertex is at 0, 0, and the a value is 1. All right, and then that's what we assume some of those comparisons are made to when it talks about shifting right and left, up and down, and those kind of things. Okay, so now let's look at A here. All right, opens up, has a rate of change of 6 and a vertex of 5, negative 6. All right, so y equals, it opens up, we know it's positive. Now it tells me my rate of change is 6. Now remember, that's not our a value. So the a value is our rate of change divided by 2. So to get my a value, I have to do 6 divided by 2, which means it's positive 3. And then I take my vertex and I plug it in, so x minus 5, and get that square on the parenthesis to make it quadratic, and then minus 6. All right, there you go, and that's it. That's all the work you have to do. Now looking at B here, now we know it opens down. And I'm going to jump over here because now it tells me my rate of change is negative 4. So once again, to get my a value, I take my rate of change, right, and I divide it by 2. So negative 4 divided by 2 is negative 2. So there's my a value. Now, once again, it says shifted to the left and down 3. So shifted to the left means my x value is negative 2, right? So I'm moving to the left of 0. And then if I go down 3 units, that means my new y coordinate for my vertex is negative 3. So x minus negative 2 becomes a positive 2 squared, and then minus 3. All right, so you can see that there's really not like a lot of like work to do here, but there are things that you have to know, and there's no workaround. So the hard work is making sure you know all the language, the forms, right? The connection between rate of change and a value. That's really the biggest piece. The actual math is not that difficult. The preparation to do the math is the difficult part, and that's what you have to make sure you know. All right, so now part C here, it says we want our parent function to be reflected over the x-axis. All right, so once again, that parent function, right, looks like this. Opens up, vertex is at 0, 0. Now, if we wanted to reflect it over the x-axis, instead of opening up, we want it to open down. So all we have to adjust to do that is our a value, all right, and we just want to make that negative and then x squared like so. And then we're done. That's it. All right, so now notice the change in part D here. We want it to open down, and I'm going to jump over here with an a value of negative 1/2. So notice this time it tells us the a value. So we know right away that we want it to be negative 1/2. All right, opens down, we know it has to be negative. That's all good. Now we have to find that vertex. So shifted to the right 21 means my x coordinate is going to be 21. Up 33 means the y coordinate is going to be 33. And then I can put that into my vertex, into my equation, and that wraps it up. Okay, 2 more. Now, once again, here we see this language, right? Wider and narrower. And so I have to associate that wider and narrow, right? Okay, where'd it go? There we go. All right. Okay, with narrower and wider is going to affect our a value and only the a value. Okay. All right, so now opens down. And I want it to be wider than y equals 3x squared. Now, once again, like I said last time, we want to adjust the wider or narrower first and then make it open up or down. Those are 2 different things. So if I want it to be wider than this, I need my a value to be smaller. I need it to increase less fast. All right, so I need a number smaller than 3. So I'm just going to go with 2. Remember, you could pick any number smaller than 3. Okay. Now, if I want it to open down, now I assign the negative to that. That's going to now make it open down. And now I can use the other information to find my vertex, right? Shift it to the right 2 and up 7. So my vertex would be 2, 7. So x minus 2 squared, all right, and then plus 7. All right, there's our equation. So remember, I would do the wider or narrower first, okay, get that number set, and then assign the number to, or the sign to the number to make it open up or down. So let's look at F here. Opens up, and now I want it to be narrower than y equals 5x squared. So to be narrower, I want it to increase faster. I want it to go up, right? So now I'm going to pick a number bigger than 5. I'm going to go with 10 this time, just to make it a lot bigger. So that's going to increase a lot faster to be a lot narrower. Now I want it to open up. So then I want this new a value to be positive, which it already is. So I'm good. And now I have to find my vertex. So shift it to the left 6. So that means -6 for my x, down 4 means -4 for my y. And now I can plug that in, x minus -6 and then -4. So hopefully you can see that a lot of the things we've already talked about transfer from absolute value to quadratic. All right, but if you have any other questions, all right, make sure you write them down, circle the number, circle whatever you have. All right, bring those to class and we'll answer those next time. See ya.